Good afternoon, Robert Scribbler. It is July 31st, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I am going to delve into a controversial subject matter, and that subject matter involves arguments against climate action. Now, we're all pretty familiar with arguments against climate action as they relate to climate change denial. That being that climate change isn't happening, people for whatever reason don't believe the science, primarily due to their association with fossil fuel interests, and therefore they say, well, why do anything because there's not a problem. Of course, this is a false statement. But there's not just one argument for climate inaction, and all arguments for climate inaction are harmful. And one of the main or emerging arguments for climate inaction is the opposite response to climate change denial. It's a hard swing from there's no problem to, well, the problem's so bad that we're doomed and we can't do anything about it, so therefore we shouldn't. And that is also a false frame. Now, I'm going to discuss with you a couple of pieces of this false frame and describe where we are with regards to human-caused climate change. I'm also going to dig into a matter that most people who are focused on the doomer side of the equation, the people who are saying, well, climate change is so bad that we can't do anything about it, and that is methane. And so I'm going to talk about all these things, so hold on to your hat. We're going to go through a number of issues. Now, the first issue is, how bad is climate change today? Now present human-caused climate change has, in my opinion, risen to the level of a global crisis. Now, this is not to say that we have hit catastrophic levels of climate change, and if we don't halt fossil fuel burning and human-based carbon emissions, then we will eventually get into catastrophic ranges. And the way we can think of climate change impacts is on a rising scale that is roughly equivalent to how much the world has warmed versus the pre-industrial average, which is typically shown as 1850 to 1900. And in the NASA average, we basically have been using the 1880s measure because that's when the NASA temperature record starts. But it's basically the same range. And presently, we have warmed by about 1 to 1.2 degrees Celsius above the 1850 to 1900 range. And so if you look at that range, it puts us about here on the IPCC graph of reasons for concern. And in this graph, the IPCC has broadly given level of risk due to human-caused climate change and threats to unique systems, threats of extreme weather events, disruption to human civilization based on the impacts, and large-scale singular events which could be described as very severe catastrophic events. And you can see that right now in the first three, we're in the yellow range, which means that we're presently showing moderate risk of such events, and we're in a rather low risk range for singular large-scale events, which means we're not yet in a range where serious catastrophic events are yet a major risk. But disruptive events that impact human civilization, such as severe droughts and systemic cascading effects, such as multiple extreme weather events occurring at the same time, or just generally increasing extreme weather events, which we certainly are seeing, and threats to certain unique systems such as coral reefs or unique habitats due to climate change are on the rise in the moderate and in some cases starting to edge a little bit closer to the high range. So these impacts represent a crisis that is ongoing today and that we are starting to see impact human systems and natural systems on an increasing scale. But if you look at this scale, this temperature scale, and of course it's a simplification, but you can see that present impacts are nowhere near as bad as they would be if we get above 1.5 degrees Celsius, or above 2 degrees Celsius, or above 3 degrees Celsius, and on and on. And so there's a sliding scale of climate change impacts. And what this means is that there's a large space between everything is fine and we're doomed. And we're in the first stages of getting into everything is not fine. And that's where we are today. So fear-based communications often have a tendency to freeze people, or to freeze people in various mental states. And what I'm trying to do is provide you with information so that you can be empowered to deal with some things that may look a little bit scary and make rational decisions in a situation that is admittedly more difficult. Now I'm going to go ahead and drill down into present atmospheric methane. Now the reason why I want to talk about methane is one of the objects that people who are focused on climate doom, immediate catastrophic climate doom, which is a fallacy, tend to focus on. And as we can see, the location now, but I want to say before I go on is that the methane emissions and feedback are both a concern due to human-caused climate change. And it's something that we need to monitor and we need to think about accurately. But we don't want to get into extreme or polarized views, particularly inaccurate views. Now, looking at surface methane emissions, we can see that primarily methane emissions are coming from areas of high industrial activity and fossil fuel burning in the US, in China, in Europe, in Russia, and in parts of the Middle East. In addition, we have methane emissions in the tropics, which are somewhat expected, especially as you see increased wildfire activity. And also we have methane emissions in wildfire hotspots, such as large wildfires presently burning in Siberia and in parts of Northern Europe. Where we don't see high methane emissions, but where we see a bit of a methane overburden is in the Arctic. And in areas where sea ice has been reduced, we might see a little bit more in the way of surface methane emissions, but nothing in anywhere near what we would consider to be catastrophic. Now, looking at the overall forcing for methane, this is why methane is a bit of a misnomer when it comes to climate doom, is that present radiative forcing, the majority of which is produced by CO2, CO2 weighs very heavily on the amount of added heat trapping to the Earth's atmosphere. And present methane heat forcing is about 1/5 to 1/4 that of CO2. And so it's a gas, a greenhouse gas that we need to keep track of and something that we need to be concerned about. But present methane levels in the global atmosphere are not spiking. They are rising, and so that's a concern, but it's not anywhere near along a catastrophic track. So if anyone says to you that the world's going to end tomorrow because of methane emissions or because of methane feedbacks from places like the Arctic, then they're not really telling you the truth. There's no indicator right now that that's happening or that process is now underway. But we should be very clear that methane emissions and methane feedbacks are a concern as it relates to the present global climate crisis. And this is a crisis, and a crisis that includes many moving parts. But we need to look at each part and understand each part in a way that is accurate and not to exaggerate and thus misinform the public. So thank you for joining me, and I'll be chatting with you soon.